Inheritance is one of the fundamental concepts or tenets of object-oriented programming. There's plenty of technical explanations out there, and we'll build on our simple explanation here right up front, but let me give you a good definition as we get started. Inheritance allows one class, which we normally refer to as the base class or a parent class. So just take one class that has properties and methods, and it allows another class to inherit or to have the same methods and properties merely by saying, I want to inherit from that class. So a second class, which is usually referred to as the child or the derived class, will inherit the properties and methods of the parent or the base class. All right. So therefore, the child will have all of the parent's properties. That's why they call it inheritance. So if you are coming here from the C# Fundamentals course that you may have seen on Microsoft Virtual Academy or on Channel 9 or here on Developer University, then this is a good course to go to next, because in object-oriented programming, all begins and ends with inheritance, and we're going to need to get this under our belt to move on to other concepts like dependency injection in order to build more interesting applications. So you should already be familiar with classes and objects and namespaces and methods and properties and things of that nature. In other words, take a look at this little application that I've built. In fact, it would be a great idea if you pause the video and you create a brand new project called Inheritance 01, just like I've done here. So we'll go File, New Project, and let me resize this to get it in the recording area. You'll want to go to the Windows Classic Desktop. If you don't have that option, then you did not install the necessary workflows or workloads whenever installing Visual Studio 2017 or greater. All right, so you should have that. Windows Classic Desktop, make sure you choose a console application. Now, truth be told, this will also work with .NET Core, a console application, but we're not going to use that for this course, but feel free to if you want to. It's going to be the same no matter what. And then you want to call this Inheritance 01 like I've done already. And then you'll want to, first of all, start by creating a new class called Automobile and create some properties and some methods. Here I just have 3 properties, a make, a model, and a year for an automobile. And then we also have a drive method that does nothing but just print out the properties that were set for this given automobile. So here we use the string interpolation character, the $, before the double quotes, and in curly braces, then we address the properties that belong to this instance of the automobile class. All right, if that didn't make sense to you, what I just said, then you may be getting a little bit ahead of yourself. You should go back and watch particularly the last half of the C# Fundamentals course that I originally created for Microsoft Virtual Academy, but that you can also see here on DevU. Okay, so once you've created that class, now you should be able to actually use that class. And so we created a new instance of the automobile class, and we're using this syntax that allows us to set those properties right at the point of instantiation, right? So we're going to set make, model, and year, in this case to Toyota 4Runner 2017, and then we're going to call the drive method. So let's go ahead and run our application just to make sure it works. All right, and it does nothing other than to print out what's in that silly drive method, right? But what we want to do is create another class. Let's close that. Another class that actually derives from automobile, and you'll see the value right away of working with inheritance. So let's create a class called truck. All right, and here we're going to just leave it alone and do absolutely nothing with it as we get started here. So let's go ahead and just say var truck equals new truck. And you're saying, Bob, this is madness. And I'll say, watch this. Make equals, wait a second, nothing's happening. Okay, so that's what we need to do in order to inherit from the automobile class, we're going to use the colon character on our keyboard and then the name of the class that we want to inherit from. And so in this case, automobile. All right. So you can see that it found a reference just here in my IntelliSense in Visual Studio 2017 to automobile. So now when I come back up here to make, see, I get some IntelliSense, and I'll say I'll also make this a Toyota, and if I can spell it correctly. And then we're going to do a model. Oh, is that the Tundra that they have? I don't own one. And then we'll go ahead and set the year. You can see IntelliSense there. That means it knows what it's looking for here. Let's go 2016. All right. And then we're going to go truck.drive. And now let's go ahead and, after you have that, hopefully you're following along, let's run the application. And you can see that we have now a second line in our output that the Toyota Tundra is driving. All right. So what do we do here? Again, this derived class, the child class, the truck class has the same properties of the automobile class. It has the same methods as the automobile class because it's inheriting from automobile. But here's one thing that it can do as well. It can then extend the parent by adding new properties and methods. So we can make a specialized version of an automobile called a truck. And trucks have additional things that we might be interested in. So we might be interested in, for example, let's go prop, tab, towing capacity. So we'll just use int towing capacity, enter, and then prop, tab. And we'll just use int again for cargo size. All right. And we might even implement another method like public void tow. And here we'll do console.writeLine, and then now we're towing. All right, so let's go back up to our original example where we consume this. And here, let's set, actually, here, let's do one more thing. Well, we'll leave it at this for now. And, oh, actually, I'm sorry, let's towing, and then we'll say towing capacity, right? And we'll just call this pounds or whatever unit of measure you want to use. And so now we'll go ahead and set the towing capacity equal to 1,000, all right? So what if we try to get to towing capacity from our automobile? Towing, I'm not getting any IntelliSense, and I'm getting a red squiggly line, which means it does not like this. Why? Because towing capacity is not a property of the automobile. We specialized a version of automobile called truck. It makes sense in the context of building a truck so that when we want to display it, when we're towing, calling the tow method, we'll see what we want to see in the output. And so here we go. Now we're towing 1,000 pounds. Awesome. All right, so as you can imagine, there's a lot more to it than this. This was just a very simple inheritance example. But I think where we'll go from here next is that we're going to talk about how to replace the parent's implementation of various methods. That's something you're going to commonly do with a child class. So, for example, I want to take the drive method and change it to include maybe the cargo size in the drive method. And we can begin to talk about what inheritance actually does for you as you're building your applications. You can see here that it allows us to compose new objects like the truck object, extending the functionality of parent classes like the automobile class. And inheritance, this technique, this tenet of object-oriented programming, is really the basis for many of the tactics and the design patterns that will help you write more flexible software. Later, I'm going to show you how inheritance enables something called polymorphic behavior. Polymorphism is another tenet of object-oriented programming. Polymorphism allows a method to work with the child of any parent object. So we'll see how that is enabled here in just a few videos from now. And as you can imagine, there's many variations on how inheritance actually works. And frankly, if you're hoping to get a job as a software developer, you're going to always need to know this inside and out, no matter what. It's going to come up on every job interview, at least in some form. So what we're going to do in this course is start real simple. We're going to take this example and we're going to try to understand it a little bit better. We're going to then build on this example. We're going to include lots of challenges for your practice, and we're going to add detail, and then also we're going to start doing something new. Instead of a cheat sheet, we're going to go to a index card format so that you can review some of the most important distinctions and ideas related to inheritance right before you go into your job interview. So it just refreshes your memory of all the things that you learned in this course. And we'll build a stack of cards for this course that you can include with all the cards from all the courses that we're going to build from now on. All right. So we'll get started in the very next video. We'll see you there. Thanks.